All right, next up on our Endstops and explanations, I want to talk about transistor type sensors. So instead of having a mechanical switch of some kind, let's draw my infamous end stop connector here. Plus 5 volts and my ground and my signal. So instead of having a switch here that would open and close to indicate my state change, what I would have is a transistor output from a sensor. Now, what is a transistor? I'm not going to go into everything that a transistor is, but I just as far as much as I can as it relates to connecting some type of a sensor to an end stop. If I were to pull up a schematic like this, and this is some type of a sensor, and it's got a brown wire that goes into it, that's my plus side, and a blue wire, that's my minus, and this black wire is my sensor output. Now, people often think of sensor output as being a signal that goes out from something, but in this case, and in a lot of industrial applications, your output is actually taking that signal and shorting it to ground. And that's what this guy right here is doing. This is the schematic symbol for a transistor. So if I were to draw out a transistor like this, and this is an NPN, the little arrow is not pointing in as compared to a PNP, which it is pointing in. Just ignore the other P. I don't know, that's how I learned it anyway. So the type of sensors I'm going to be working with are PNP sensors. Now I'll explain more about PNP sensors in a bit. So a transistor works in this application. Again, I'm not going to explain everything and every type of application a transistor can work under, but in this case it is called a switching transistor, meaning it is acting like a switch, like we have talked about in other videos. I'm not going to recap that again. You can go watch it if you want. But a switching transistor turns on and off. So, okay, I guess I'm going to recap a little bit. I've got a schematic, little breadboard over here. I've got a red wire that's 5 volts and my black is ground. And this left side of the circuit here is 5 volts, and then it goes through a resistor that is 150 ohms. The value at this point is not important. A light emitting diode and a switch, and then it goes to my ground. So right now this is an incomplete circuit. I do not have a complete path from my 5 volts through all of my loads, through the switch, and to ground. If I were to close that switch, and I'm going to push on this button right here, that's my switch, my LED comes on. Yay! That is a complete circuit. When I close this switch, current flows through all of these components and creates a complete circuit, and it does its work. When I let off of the switch, not a complete circuit. No current flowing, nothing gets done. All right? That's what a switch does in this circuit, is it completes my circuit. Now, if I wanted to use a transistor to do that, and that's what the other half of the circuit here is doing, and I'm going to move my switch connector to, I'll draw it out here in a minute, from here to here. All right. So what I've got now on the right side of this breadboard here is I have 5 volts, and that is going down to, make sure I get this right here, a light emitting diode through my transistor and to ground. Now, this is the primary part of what you're going to be focusing on if you're using some type of a transistor output sensor. But in order to turn this transistor on, I have to have some type of a signal. There we go. Okay. some type of signal to turn this transistor on. And how this gets turned on is mostly, not completely irrelevant, but mostly irrelevant to the output of the sensor. I just have to be able to turn this on somehow. But this is the same schematic, this right here, as what I've got right here. So when I close, I'm going to redraw that, my switch, my LED comes on. All right? So what's happening there is I have turned on this transistor, and now I have, use a different color here, I have a complete path from my 5 volts through my light emitting diode, through my transistor, and to ground. All right? And for anybody who's saying, how come you don't have a dropping resistor on that LED? It is a 5 volt LED that I specifically bought for a project that is made right there. LED 5mm 5 volt. So it's designed to take 5 volts in and not need a drop-in resistor. So nobody freak out over that if you're ahead of the game. So that transistor is acting just like a switch. Okay? It's either open or it's closed. And when I energize the transistor, then I have a complete path, just as if I closed that switch in the previous circuit. Hopefully that makes sense. If not, make a comment or message me or whatever. Glad to explain it more because I'm going pretty fast here. So if I have a sensor output and I'm showing this this web page diagram here, if I have this sensor output and I have a transistor here in this circuit connected to my output, what that is doing is completing my circuit from my positive to my load, through this transistor, and back to ground again. That is completing my circuit just like a switch. Okay, my load in this case is the LED that I've got, right here, the light emitting diode. So whenever you see this transistor symbol, think of it as a switch. Think of it either being fully open or fully closed, either completing a circuit or allowing the circuit to be open. That's 99% of what you need to know when you are trying to interface some type of transistor type sensor into your end stops. Can I prove that? As always, I'm going to prove it. So I'm going to redraw my circuit here so that I've got my 5 volts and it's going, let's see, how did I draw it? A resistor and my switch that goes to my transistor and my ground, and I'm going to leave this open. Now you'll see this in different types of sensors when they are describing the type of sensor it is. They call it an open collector. And I didn't actually describe, wow, I can't write at all. Didn't describe these pins here, but this is the emitter, this is the base, and this is the collector. These are the 3 pins on a transistor. And open collector means that it is not connected to anything, that it's open. It's free for you to connect something to it. So open collector means that we're going to have this path be separate from this path. Oops, nice job. So draw it again. 5 volts. My switch to turn it on. Transistor, there's my ground, and there's my open collector like that. All right, so what I'm going to do is take my ramps board here. Actually, I don't need it fully in shot. I'm just going to stick it over here. And let's see. I'm going to draw it one more time so I have a little more space here. So, getting really good at drawing this. All right, open collector right there. So on my ramps board, I've got my plus my minus, and my signal. What I'm going to do is connect this to ground. It's the same potential as this ground here. If you're not familiar with electronics and electricity, it's the same as if I had both of these connected together. You see on a schematic where you'll have a ground symbol all over the schematic. And when you see it, that means those points are electrically the same. They actually are, it's just not drawn that way. So, because this is acting just like a switch, and I want to connect my signal pin to my ground, well, my ground's already connected there, I'm going to connect that open collector to my signal pin so that it acts like the switch. So if I take my LED out of my circuit and I take this cable that is very long, so I just tied a big knot in it. And let's see, if I want to go from, there we go. So I've connected it one side to ground and one side to my open collector. These do have polarity. They have to be connected. This side has to go to my signal because this is going to be positive 5 volts here. I've got my pull-up resistor enabled, so I'll have 5 volts on this pin, so I have to have, I can't reverse this, so I do have to be careful with that. Actually, let's make sure I'm being careful with that and look at the connector and make sure that the polarity pin, the pin is on ground there. Good thing I was talking to myself to remind myself to do that. Alright, and the pin is in ground here. Alright, so no smoke, awesome. Voltage regulator staying cold, also awesome. Alright, so when I go and look at my end-stop status, let me pull up, oh, okay. My end-stop status says that it is triggered right now. Because I have it inverted in my firmware. Let's see, this was X-min, so let's see here. Use the X-min plug, and oh, there we go, come on computer. And X-min is defined, and let's see, X-min is false, meaning it's expecting a closed switch there all the time for it to be open instead of inverted. So when I close my switch, let's watch my X-min, says it's open. My end stop is open right there. And that it means my transistor is now turned on. And here, let's make this easier because what I've got here is opposite of what you'd expect. I'm going to go to my X max. All right. X max says it's open. When I turn on my transistor, it says it's triggered. All right. So hopefully that made sense too. It doesn't matter whether this is, you know, a high active or low active, as long as you've got it set in firmware correctly. So I'm actually using the output of this little transistor right here to short my signal pin to ground, and that is again just acting like I have an actual switch there.